Hello everyone, welcome back to my YouTube channel, and in today's episode, let's explore the performance of pandas with GPU and polars. So let's dive into it now. We will run this code in Google Colab, and we will need to specify in the runtime environment a T4 GPU machine. We do this so we can have GPU in our virtual machine. Also, we will need to download a large dataset because we want to test the performance of pandas GPU and polars against pandas. And if the data is not large enough, we might not see any impact on the performance. So that's what I will do here. We will first run this command to see the machine assigned to us. So we have a Tesla T4, and then we can proceed to download the dataset. So the data is New York City parking violations 2022. In this case, we will take a sample of 10 million rows, and we will save this data in a file called New York City parking violations 2022 sample.parquet. We proceed to take a sample of this large dataset because in some of the cases, when the data is so large, we might need to use an environment with more RAM. So in this case, I'm just taking a sample of 10 million rows, which will be enough to analyze the performance of pandas GPUs, and polars. As you can see here, if I click on resources, you can see that the RAM is almost gone, 11.9 out of 12.7. That's why I take this sample, because if I keep analyzing data on this VM, it might crash. Now that we have our data in our environment, let's proceed to shut down the environment, and then you will see that all the resources went down. So now we can proceed to analyze the performance of this data set using pandas. So the first step will be to import pandas and then read the dataset. That's what we do here. Let's execute this chunk of code and see how long it takes to load the dataset. So we can see here that the total time to load this dataset was 24.9 seconds. And if we want to check how large is this data, we can check the columns that it has. So let's do GroupBy Pandas and then shape, just to give you an idea on how large this dataset is. So it has 10 million rows and 43 columns. But in this case, let's just analyze these columns. So let's filter this data by executing this code. We will be selecting just these columns, and it took 0.6 seconds to filter the data. So it was quite fast. If you're enjoying this content so far, don't forget to subscribe to the channel by clicking on this button because it helps me to create more content. Smash the like button and turn on the notification bell so you never miss a new video. And then if we want to make any aggregation, which is one of the reasons why we use pandas, because we want to do some data analysis, let's proceed to make this aggregation. We will select these three columns. Then we will group by registration state and the vehicle make. We will count the amount of occurrences of some numbers, which will basically be the count of infractions for state and vehicle type. Then we will reset index, and then we will sort the values by their result in descending order. So let's execute this cell and see the results. As you can see here, we have the registration state, the vehicle make, Honda, Toyota, Ford, and so on, and then the result, which are the infractions. And we can see that this aggregation just took 2.57 seconds. Taking into consideration that we're dealing with a 10 million rows dataset. Let's perform another aggregation. In this case, let's transform the column violation description to uppercase, because sometimes it's uppercase while in other cases it's lowercase. Then let's filter by registration state in New York. Then let's group by violation description and count the infractions again. So they are similar operations, but in this case we transform to uppercase. We also filter data in cases in which the registration state is New York, and so on. So here we can see that it took 6.52 seconds, which is not that bad. Let's proceed now to create another table, because I want to show you how fast it is to perform a join between two tables. So in this case, let's take the violation code and let's drop the duplicates, and then we will categorize the violation code in three groups. If it's lower than 20, it's small. If it's lower than 50, it's medium. And the violation, if it's bigger than 50, we will consider it as severe. The whole point of doing this is just to have another table with the violation code and the category of the violation, because we will join the violation category to our pandas data frame. That's what I want to show you. So let's execute this code. Let's apply this function, and then let's proceed, as I said here, to join the data frames. So if we use the GroupBy Pandas, which has the 10 million rows and 7 columns, and join by violation code with this table 1 PD, which has the violation code and also the violation category, let's see how fast it is. Here we can see that it took 2.72 seconds, which is quite good. Here we have the same table, and then with the added column, which is the violation category. And now let's see how much memory it took to do all these processes using pandas. Here we can see that it took 1512 megabytes memory, which is okay. And now let's proceed to see the results using pandas GPU. So first, let's clean our environment. Let's shut it down. And one of the advantages of using Pandas GPU is that you don't need to change the code. You can still use your same Pandas code and just add this line of code in which you specify that you want to use cuDF Pandas. So let's execute this code and also import Pandas again because I restarted the environment, and also cuDF. So as I said, you don't need to change anything on the code. You just need to use the load extension of cuDF Pandas and that's it. That's one of the biggest advantages of using cuDF Pandas, that you don't need to make any change in your source code. Let's execute this cell and let's load the dataset, and here we can see that it just took 1.05 seconds. And if we go back to Pandas, we can see that when we run that cell using Pandas, it took 24.9 seconds. So as you can see, it goes down from 24.9 seconds to 1 second if we want to run it using Pandas GPU, which is amazing. Now let's filter the data. Here we see that we can filter the data. It took just 2 seconds. And then if we perform the aggregation that we saw earlier, we can see here it takes 4 seconds. And if we go back to Pandas, we see that it took 2.57 seconds. So in this case, the aggregation using Pandas was faster than the aggregation using Pandas GPU. Nonetheless, this could be because the data was not large enough. Let's perform the other aggregation. Here it took 6.52 seconds. Let's see now how long it will take if we execute it using Pandas GPU. Let's execute this cell of code. So in this case, it took 4.19 seconds. So it took 2 seconds less using Pandas GPU than using Pandas, which is very interesting. So here we can see that this one took longer using Pandas GPU, but this one took less time using Pandas GPU. And now let's check how long it takes to do the merge. Let's run this cell of code and perform the merge now. Here we can see that the merge took 0.1 second, which is super fast. But then if we check how long it took using Pandas, we can see that it took 2.72. So we see a big difference in time. You could say that the time difference is not that big because you go from 0.1 to 2.7 seconds. But when you have a very large dataset, that will play a big impact in execution time. Also, here we can see that the memory using cuDF was 1000 megabytes, and when we go to Pandas, we can see that it was 1500. So we're using less memory when we use Pandas with GPU. So as a first comparison between Pandas and Pandas GPU, we can see that in every field, Pandas GPU had a better performance than Pandas, except on the first GroupBy that we performed. And now let's see with polars how these results will look like. Let's go to polars now. Let's import polars and then let's load the dataset. Let's see how long it takes. It's very important to point out that if you use polars, you will need to change your source code because it has different functions than Pandas. In this case, we can see that it took 17.8 seconds to load the dataset using polars. So here we can see that polars took longer than Pandas GPU, but less time than Pandas, which is very interesting. And now let's go to the second operation, which is filtering the data. Let's see how fast it is using polars. Well, it took 2.38 milliseconds, which is more or less the same as using Pandas GPU. So it's a bit higher than Pandas GPU, but less time than using Pandas. Now let's proceed with the operation in which we perform the first GroupBy. Let's execute this code. And here we can see that it takes 1.17 seconds. Let's check how long it took with the other approaches. Wow. So we can see that this first GroupBy takes less time using polars than using Pandas and Pandas GPU. It takes 1.17 seconds. Now let's check a second GroupBy. Let's execute it. When we execute this code, we can see that it takes 4.12 seconds. And when we make the comparisons, we can see that it's also faster than uses Pandas GPU and Pandas. So polars is having an amazing performance when we perform operations such as GroupBys and filtering the data, but it's considerably slower when we load the data. Now let's check the join operation, which is a very frequent operation that we perform when we do data analysis. So let's execute this code. When we see the results of joining the data using polars, we can see that it took less than 1 second, which is amazing. So it took 0.89 seconds, which is great. So for the join operations, polars was slower than Pandas GPU, but considerably faster than Pandas. Now let's check the memory used. When we execute this cell of code, we can see that it took 2000 megabytes. So it's double of using Pandas GPU and also higher than using Pandas. What we see from this table is that Pandas GPU was the fastest to load the dataset, and also it's the fastest when we filter the data. But when we make the GroupBy operations, we can see that polars was the fastest. But when we perform the join, we can see that Pandas GPU is faster than polars and also faster than Pandas. And in terms of memory consumption, we can see that Pandas GPU consumes the less memory. So here we can see that Pandas GPU and polars are very good alternatives to Pandas. If you have the option to use GPU, you could go to Pandas GPU because it's considerably faster. But if you don't have the option to use GPU, then you could go for Polars when you have a large dataset. So it will depend on the resources that you have available at that moment. And that was it for today. I hope you liked this video tutorial. If you have any type of questions, please leave them in the comment section below. Don't forget to subscribe to the channel because it helps me a lot. Smash the like button below and turn on the notification bell so you can be the first one to know when I upload a new video. See you next week.